I'm going to introduce Shawn Moyer and Nathan Hamiel. And Nathan's a good friend of mine. We've been friends for about 4 or 5 years, and I've always been very impressed with his work. If anybody here has followed some of the things that they've done over the past couple of years together, it's been very exciting and very impressive. So I don't think that this talk is gonna let anyone down. So without further ado, weaponizing the web.
Well, let's hope it doesn't let anybody down. And we have another problem because we have no power up here. So I don't know. I guess we'll be testing the limits of my battery life on the MacBook. So as Joel put it, I am Nathan Hamiel. I'm a senior consultant for ID information security, an associate professor at UAT. I founded the Hexagon Security Group. And apparently, as of this morning, I'm a 23rd Mason. And I'm a lava rolling enthusiast, and you'll see some of that later.
And yeah, I'm Shawn Moyer. I'm a principal consultant, so I believe I actually outrank Nathan.
I manage the technical security team at ID. I was just being nice.
Both people on the team. And yeah, I do these kind of things periodically for no reason that I can actually explain, especially at 5:30 in the morning, finishing slides. And you know, it's commonly held that I shot a man in Reno just to watch him die. So kind of just a preview of some of the things that we're talking about. There's a series of kind of some observations on kind of where the web's going right now and sort of what we do with the web and the internet, which is sort of what I described as the democratization of misinformation. You know, you used to get your erroneous information only from newspapers and you know, traditional media. Now you can get bad information from blogs, wikis, Twitter, you know, lots of other sources. Also kind of talking about the move towards a lot of integration and shared exposure across different sites on the web, and a lot of this content aggregation and integration that's going on. And some of the emerging attack surfaces that are starting to come about from that. And then some actual information and content as well. So I'll let you actually hit that.
Part of what we kind of kept under wraps a little bit is we were working on a nifty new approach to an old attack, which is cross-site request forgery. How many people here know what cross-site request forgery is or have an idea of how it works?
The rest of you can go. Just come back, read Wikipedia, you know. And actually, I'm picking on you. We'll go into kind of a high-level overview, and those of you who do know what it is can go smoke or, you know, have a drink, come back.
But it might happen fast.
Probably fast, yeah.
So we're releasing a tool today, and that is available as of right now. So, and it works for the most part. We used them for the demos. So anybody who says it doesn't work, it didn't say it worked well, but it works. And some API tomfoolery as well will be included. And yeah, we're going to rant a little bit, which we know everybody just loves to hear, but some of it's necessary.
Mm-hmm. So yeah, so it's been kind of hard to explain, you know, when we say user-generated content, kind of what we're talking about. And, you know, we really actually, just a minute ago, somebody said, you know, so this is a sequel to last year's talk. And we said, you know, we
it's
absolutely...
an injected talk from last year?
A sequel injected talk from last year. We really, when we were looking at kind of this problem last year, we kind of saw that a lot of this related to social networks, but it really kind of has become more and more kind of pervasive across the web, so we really didn't want to constrain it.
During the following portion of this presentation, we experience technical difficulties. The problem does get resolved, and the quality will improve shortly. Thank you for your patience.
Problem with user-generated content. And that's, you know, just basically, if you think about all the sites that you visit on a daily basis, very much so anymore, just like a kind of a show of hands, how many people found out that Michael Jackson died via Twitter? I did. I'm embarrassed to say. And it's not much better if you didn't, you know, get it from there. The next, you know, the actual news outlet that broke the story was TMZ, you know, which isn't much better. So it's kind of this move towards all of these things being very collaborative and social across the board, and even seeing that kind of get integrated into old media kind of websites. blogs, wikis, all these different kind of web communities that we all sort of consume now. And like I said, that's increasingly more and more now getting retrofitted onto some of the traditional web. And so there's a lot less of this kind of one-way conversation. Pretty much any even old media website has like a blog section or a comment section or some place where you share information. We'll talk about some of that.
A lot of functionality is now getting further integrated into applications. So what we don't see a lot of anymore are popular websites that are purely static in nature, or some kind of brochureware sites. They're obviously not as enticing as a place that you can go to, that you can add and customize yourself. Maybe you can get news, or you can aggregate your feeds in one simple location. You can get all your news in one spot. Those are the kinds of things that are increasing in attack surface of sites and applications. A lot of these sites allow you to link to things off-site, even if it's in a controlled manner. So it might not be as simple as maybe you can't put any markup on a page as far as image tags goes, but maybe you can provide a hyperlink somewhere, and maybe that hyperlink can then further be shortened, and many other scenarios for that. We're seeing a lot of aggregation points lately because people communicate on many different sites at once. So maybe you don't want to log into Facebook, log into MySpace, log into Twitter, get your news and everything from all these different locations, because it's kind of a pain to keep all of them updated. So if you wanted to say, hey, this is an update and this is what I'm doing right now, it's easier to do it in one spot and let that aggregate out to multiple sites. And there's an increasing resilient or increasing client-side logic component to this. So a lot of this stuff is happening on the client side, and that also gives you further things to look at as far as information leakage and some interesting errors and things of that nature.
So I'm pretty sure we're probably the only Black Hat talk that's going to mention 4chan, as far as I know. But actually, and there's kind of a series of this, of just kind of some observations of things that have been happening here just recently on the web that are kind of interesting as far as you. So I think most people is already kind of aware of Marble Cake, also the game. Wow. Okay. So
one person.
Okay.
Give that man a beer.
So I will tell the painful, kind of boring story here, which is Time Magazine has a Person of the Year poll, and this year Moot, who is, I guess, kind of the founder of 4chan, was one of the nominees for the Person of the Year, and so that then created interest on the part of that community in the poll itself, and so they very quickly built a series of different sort of auto-voting scripts that they placed over, different websites around the web that voted up Moot. And they managed to get Moot kind of to the top, and then decided that wasn't really quite interesting enough. So they decided that the Person of the Year poll for Time Magazine should actually be an acrostic that spelled the words Marble Cake, also the game. So that required a series of automated scripts that went out and looked at the different nominees and gave them votes up or down based on the first letter of their name, so that things would then arrange into that form. Along with that, which is kind of where this, to me, is kind of interesting, Time kind of caught wind of that and said, well, we're gonna solve this problem. And so they attempted to implement some tokenization and like CSRF protections, and that stopped the voting for like a day or two, until it was discovered that the tokens were being issued by a flash object. It wasn't. Developers in the room don't do that. So this was a flash object that handed out this token, and so the scripts then were all just modified to go out and get the token first and then vote, right? And so, yeah, you can kind of see that the end result of that is, I think, Moot had 12,939,521 votes. And it kind of goes down from there. But the interesting thing to me about this is not really all of that, which is just, kind of general, internet tomfoolery or whatever, right? It's that Time's response was to say, well, everybody knows that internet polls are not to be trusted. This isn't useful information. I mean, you shouldn't actually trust that. Except, of course, when Time makes their, presidential predictions during elections and references, their internet poll as part of the predictors for it. So that to me is what is kind of interesting about that overall in looking at user-generated content on the web and things. So kind of along the same line, right after Michael Jackson died, there was a lot of these kind of copycat celebrity hoaxes that sort of made the rounds. So Britney Spears, and I think a lot of people know, like Jeff Goldblum, went on to The Daily Show, and Jon Stewart said, can you tell the audience that you're not actually dead? Along with that, there was a group of people that decided to report that Rick Astley had died.
Well, personally, I think that was just wishful thinking, really. I think we were all hoping that.
But what's kind of cool about that is, and that's what this screenshot is that's actually a legitimate newspaper in India that picked the story up and put it on their front page that Rick Astley had died. So, and where that was kind of sourced out of is iReport.com, and then YouReport, which is run by Fox News, iReport's run by CNN, are these sort of citizen journalism cesspools that allow random people to, offer up news and things like that. And the intent is, again, this is all like collaborative, people vote the stories down, and the idea is, well, the community at large will police itself, and a certain number of those stories actually do end up on, probably more on the Fox News website, but a certain number of those stories end up on CNN, and they're sourced from our citizen journalists on YouReport.com.
I thought we weren't going to mention Fox News after what happened last year.
Oh, shit. Okay. So, yeah, to me, again, that's what's kind of interesting about that is that a group of people decided to, sort of propagate this hoax, and it made its way into, traditional newspaper websites and things like that. A related note, please stop rickrolling. Stop it. It is over. It was funny 18 months ago. It's dead. Just let it go. Move on. And our recommendation, which we'll get to later, is lava rolling.
And if you're not familiar with the lava, you soon will be.
You soon will be.
It is the final payload in all of our attacks.
Our primary objective with this talk is to propagate lava rolling into the culture. That's really our sort of altruistic message here. I think this is my last one on these kind of rants here. I thought this one was pretty cool. There was and I think probably a number of people sort of know about this, there was a HTML URL injection flaw on McAfee's website. So you could go out to McAfee's website and essentially like in a rebate form in a post, you could put some HTML content and it would get passed on to the browser. And so it wasn't really just sort of XSS, it was arbitrary, so you kind of call that HTML injection. You could put just about anything in there. What was cool about that was that a website called ReadWriteWeb, which is this sort of kumbaya Web 2.0 website that is really kind of terrifying. If you want to know what's going to happen 2 years from now that you need to worry about, it's a good site to read. They did an article explaining how the HTML injection worked. Well, it turns out that the NewYorkTimes.com syndicates ReadWriteWeb as one of their syndicated feeds on the New York Times website. On ReadWriteWeb, they escaped out the code example of what URL injection, somebody's already picking it up. They escaped it out, so it was like and semicolon and so on, and here's a code snippet, and this is what URL injection looks like. Well, it turns out that whoever wrote the XML parser for NewYorkTimes.com didn't kind of foresee that scenario. So the article on HTML injection on McAfee's, I know some McAfee employees that are in the room actually. I'm not going to point them out because they're hanging their heads, right? So what was cool about that, and that's why, again, just sort of talking about this like shared exposure is, ReadWriteWeb's own site didn't have this problem. There was no issue there. But when it was syndicated out to another site, they escaped it in a different way. You didn't have HTML injection on your site, but somebody who syndicated you did. And so that's kind of that larger point about all of this kind of shared exposure. I have one more. Last one, I'm going to delete 2 of these the next time we do this. So just kind of one other, related one that kind of came out, just recently was Daily Cause, which, speaking of 4chan, is, I kind of think of it as like kind of 4chan for Ivy League liberals who make $200,000 a year or so. So it's a, it's kind of a liberal forum blog, kind of thing. And somebody, and I'm really not sure if I understand like the intent of this, but somebody on Daily Cause, one of the contributors, set up an account during the debates about Obama's stimulus package that went out and followed all of the prominent GOP people on Twitter and other people on the right, that they identified on Twitter, and started tweeting all of these fake stimulus facts. And so these are all just completely imaginary. $3 million for replacement tires for 1992 to 95 Geo Metros was in the stimulus package, things like that. And what happened is that all then propagated out to all of these right-wing blogs and everything else. So Daily Cause was just saying, see how easy these people are manipulated. See how how easy it is to feed misinformation. But they didn't change anybody's mind. They had more facts that contributed to a view that they already had. But it's just kind of interesting how you just create an account, make some statistics up, and those get sort of pushed out there.
So one little thing that happened last year was when we did the social networks talk, one of my coworkers had a MySpace page, and I asked him, and I said, hey, we're doing this talk on hacking social networks. I was like, oh, by the way, do you have a MySpace page? And he didn't hesitate. He's like, yeah. He's like, I'll add you as a friend. And about a month later, I ended up going on his profile, and he had a picture of himself in drag, and basically, oops, we forgot to blank out his face. Okay. And
proud of that.
So it's always better to ask for forgiveness than for permission. So we didn't ask if it was okay if we put him in there, and then I just forgot to tell him about it. And about a month and a half later, come to find out, I logged into MySpace, and it said tagged pictures of you, and I'm like, what the hell? I was like, why is that coming up as me? Well, apparently he found out from a friend who attended DEF CON and saw that picture up there, and he tagged his crotch area as Nathan Hamiel. So anytime somebody was looking for pictures of me, that picture would come up. But the whole picture came up. If you moused over the crotch area, which I don't know why you would do, you'd see my name pop up. Yeah. So he kind of got me back. And he's like, well, at least there won't be any pictures of me in drag this year. Well, apparently there is. And I haven't told him yet. Yeah. So we kind of have this view of the web now that we've gone through the user-generated, components. So RSS feeds. It's not just pictures and data tags and all this other stuff. It could be feeds and a lot of things that are generated not from the site. And that seems to be what the entire web is becoming. It's becoming this big collection of aggregated data. So if you log into a website and it gives you no functionality, people tend not to log in anymore. And really, it's not about these elegant hacks that take months and months to pull off. An attacker is going to go for return on investment. Whatever gives you the best return on investment, it's going to go with. And that's pretty much the same for anything. The path of least resistance. There's no reason to if your goal is this, there's no reason to go all the way over here if you could just go straight to there in the first place. Well,
and something that we're already kind of seeing with that is people are using, now that Twitter has added the hashtags that show like trending topics, and you'll see that on other sites as well. So it's like these are the topics that people are talking about a lot. So things that are tagged with this topic will show up on the front page, and so people are riding along with that. By watching what it is and then tagging some post with that topic and then using that to propagate malware, because that you've got a lot of eyeballs from that versus trying to push out a phish or a spam.
And by opening yourself up with APIs, either from attaching to another site's API or opening your own site up to an API, you obviously increase your exposure, you increase your attack surface. And another thing to think about is if you're opening up your app or site with an API, you better just assume that everybody's going to be able to consume it no matter what protection mechanisms, because that site or consumer can then open up another API, and we're going to get to some of that stuff too. We're also noticing something else that's kind of crazy. Legitimate software now does everything that malware used to do that everybody used to freak out about. You know, it kind of phones home and automatically does things for us, changes, assumes things about preferences. So these are kinds of, now we're seeing, you know, users who are more and more conditioned to allow malicious behavior, because legitimate applications perform malicious behavior all the time. Hey, can I perform anonymous usage statistics on this application? Yeah, not very good. Offsite links to external content. Once you allow somebody to link to something offsite, that you lose all control over the request, which becomes very bad in the next few slides. Yeah, and of course, Google APIs is everywhere now. If you want your number of characters on Twitter to show up if you're on Twitter web, you need to allow Google APIs. And one other thing that happens too is if there's a vulnerability in one of these APIs that you're taking advantage of, now you automatically see, you know, a couple thousand instances of potential attack surface on different popular sites.
Well, and we talked about some of this in the past, but keep in mind the way most of these shared kind of site APIs work is that it's essentially a sandbox. And they're allowing a certain amount of kind of cross-domain communication to occur. And the idea is that you're somewhat protected because it's in a different domain. But there's, you know, essentially if you have the ability from one other site that hooks in the API, you're going to be able to execute code in the context of that API because the browser trusts it. So, you know, like the googleapis.com kind of rant, if you're a NoScript user, and you should be, all of you, you know, if you run that all the time, you're like, oh crap, forbid, okay, now I have to allow it, you know, because I can't log in to this site or that site. So it's become, you know, more and more pervasive. But the thing about that is that becomes this conduit across all of these sites.
Okay, we're doing a lot of setup here. Don't worry, there's some good stuff coming. We just want to make sure that everybody understands, because otherwise when you pull something off, sometimes it looks like, oh, that's not a very big deal at all. So, does anybody here use Opera? What about Opera Unite? Has anybody ever heard of it?
Does the one person who raised their hand work for Opera? No? Okay.
Well, originally, when we sat down and started talking about some of this, I told Shawn, I was like, I want to go after some browsers, man. So I started collecting bugs in browsers, and then the CanSec West browser competition happened. And I know Charlie didn't go after Firefox, but I blamed him last night anyway because it was just fun to do. And well, they started fixing things, like I had an image tag to zippy problem and everything else, and those kind of went away. But then Opera was nice enough to say, we have a brand new way to approach web browsing. And what they've done is basically turn a web browser into an entire communications platform. So I realize the graphics kind of hard, but there's this thing called the fridge, and it says a fun place for people to leave notes on your computer. There is no place on my computer that is fun to have notes left. It also has an integrated web server. And you know, because people are really good at choosing which folders should be shared with the entire world. So, and I really wanted to attack this thing so bad, but the damn thing wouldn't work in any platform that I tried it on. In Windows and OS X, it wouldn't work. So I'm looking forward to them fixing it enough so it works properly, so I can at least take a look at it.
Yeah. But and actually, so I mean, we're picking on Opera, but also, you know, Mozilla's
yeah, there's other things
and
coming up too, like Jetpack and Personas, which some of it kind of seems. And has anybody ever heard of Jetpack in here? Do you work for Mozilla? Okay, so you've heard of it. I know. Well, I didn't even download it. I'm just saying.
Fix your SSLCN parsers first, then worry about.
Yeah. So there's this increasing want to give developers more power. So the theme seems to be with web browsers is they want to give web application people, not even web application people, but people who design websites, more power into the user's browser. which to me, that just sounds like fail all over the place, because these are the people who typically don't get a lot of security in the first place. So I definitely don't want them interacting with my browser in ways I don't foresee. Also, too, even simple things like personas, which if you see the screenshots, I'm actually using personas, even though I'm kind of like digging on a little bit. You know, there's some potential for fail there in the future. If you want to go take a look at those projects, I fully support Mozilla, and I hope everybody here uses Firefox. So
Well, like in the Jetpack thing, there's the video on the Mozilla site that sort of talks about, you know, how awesome it is, and it says, imagine, if you will, writing code for the browser that's as easy as writing HTML markup.
yeah.
That's not terrifying at all. That's not going to create any problem. So yeah, if Google's native client, shellcode in browser as platform wasn't kind of worrying enough, you can essentially write, if you can throw together a couple of href tags, you can write browser plugins now. So
Let's pick on Safari a little bit. I forget who it was. I've been seeing a lot of posts lately about problems with Safari, and I was afraid that they were going to hit on this one, because this one's like really in line with what we're talking about. They have this thing called top sites, and I guess there's the assumption that it's kind of safe, because you can actually see an example of it here where it's actually blocked some active content. So it's actually blocked Flash or JavaScript that'll actually block as well. So there's this kind of safening of your preview page. But what they didn't take into account is that when you do a Control-T and you open up top sites, is that it actually sends requests periodically for these pages to see if they're updated. Those pages, and somebody told me it didn't send header data, but it actually does. So if you can have a contest or something and get a page that's performing a cross-site request forgery attack onto your top sites, and then you're logged in to another site in your top sites, it could potentially pull that attack off and you'd have no idea.
And also a point to that too is the long life sessions talk, I think I'm not sure if that's today or tomorrow, but something else to check out, like in relation to that. That's a lot of the things that we see with that exposure have to do with the fact that everybody just saves their logins on a lot of these sites, and there's an incentive on the part of a lot of sites now with kind of this collaborative stuff to force you to kind of stay logged in all the time. You have to really go out of your way to de-authenticate.
Okay, so this is Adult Friend Finder, and last year we kind of got some laughs, and I realized I know way too much about this site. But it's a perfect example of attacking a site that has bolt-on functionality, because it accepts credit cards. It was never meant to be what it became. It was meant to have simple profiles and everything else. But through the years, through addition, not that I was an old school fan of it either, but
back before they sold out in the indie
before they
days,
sold out and started using Flash, I'm like all past that. So they started bolting on some features. They started bolting on chat. They started bolting on instant messaging and everything else, but they want to strictly control that. So their messaging client's written in Flash, which also is kind of strange, because you end up with some rich information leakage. That little thing circled in red that you can't read says admin, and if you mouse over the top of it, it gives you the domain admin.adultfriendfinder.com, which is a very interesting domain if you want to go poking around. I said poking around in Adult Friend Finder, that's funny. On the other side of that, this is me connecting to the chat service and talking to a bot, because it's full of them, with iChat, because they're just running Jabber. So if you want to bypass all their security policies on messaging, go right ahead and just connect to it directly with Jabber and message whoever the hell you want. They have like some length field limiting, where if you go to send an initial request to somebody, it can only be so many characters long, which is annoying. You just connect to it with something that supports Jabber and you're good to go. So let's talk more about exposures and APIs, because this is now the new hotness. It's the new thing to do, and everybody has them. Yahoo has something that we didn't really dig into too far, mainly because reading the developer documentation is boring as hell. But so we have Open Social, and then we have some new stuff, the Google Friend Connect. And one of the things to think about with Google is they've started last year. Did anybody see our talk last year? Okay, cool. So we did some stuff around open social. And open social was originally intended for opening up social networks and social network functionality to people. Now they're promoting it as an entire site. They're promoting it as an entire site API, basically, which there's a demo, or well, not really a demo, but there's an example of some attacks that obviously they didn't think about. So integrating with other sites is kind of reiteration, but so you basically have two types of site APIs. You have integration APIs that allow you to integrate content into your site, and then you have consumption APIs. And the consumption APIs allow others to take functionality from your site and display it on their site. This is interesting too, because earlier I said you can't really stop people from consuming your API if you publish one. And this is happening a lot lately too, where you'd have an application who publishes an API, which is then consumed by another application, which then publishes their API, and so on and so forth. Things like, not FriendFeed, Ping.fm does that, where you can set up your MySpace, Facebook, Twitter, all these other social networks in one place, and then they publish an API. So if you're going to publish an API, you might as well assume that everybody can connect to it and start designing scenarios around that, because each of these points is attackable. So yeah, complexity breeds exposure. So let's talk about some attacks on APIs. What you can do is a lot of these APIs have something called a proxy function, and that proxy function is put in there to allow you to get past browser security restrictions, and that's how it's documented. So it says, this function is put in here because the browser won't let you do this. Well, there's a reason the browser doesn't let you do that. It's because it's dumb. So what you can do is, depending on your attack strategy, you can actually chain an attack through all these APIs by merely calling the proxy function with no authentication. So when we get to the monkey fist tool, you could potentially set your request payload to go through multiple APIs to get the content back that it's looking for. So if there's no logging of content, it would basically be an anonymous call to the site you're attacking to get the data to fixate onto your payload.
I actually had a conversation with somebody from Google's security team last night about some of that. And he kind of said, hey, do you have broken stuff that we did? Because we're your friends. Google loves you. And the whole point that I said about it, which is the same thing that we've sort of reiterated about a lot of these things, is that they sort of just publish the framework, they make it accessible to everybody, and it's really up to the implementers of the individual sites to handle it properly. And so I mentioned some of the proxy functionality, and that we've used that in various ways. And he tells me that in the sample code and everything, there's like this massive comment that says like, "Here be dragons," please don't do it this way. Filter and ACL, all of that cross API proxied communications, but
the ACLs don't work that way though.
Right.
The ACLs, the current documentation I read on OpenSocial's API documentation is they have what's called semi-permanent storage, and I forget the exact term they use for it, and that's what they're ACLing off, because they have this way to store a certain amount of data kind of in the cloud form, as long as it's not massive. So the ACLs don't work that way. So did you go past the?
Oh, it's the same one. It's the API.
Okay.
Same one yours. So.
Okay. So what happens when you call that relayed out proxy function and give it 127.0.0.1:80? You get web pages on the development box that is running that service. And if it's bound to 127.0.0.1 and it's got a web page, it will bring it back. So I wrote a small tool that enumerates through all of these, but it's pretty noisy, so I don't want people like kicking my door down. So the problems are there. This is proof. So if you want to, go out and find more of these, because it's not good to allow APIs to call 127.0.0.1. Another thing you can do with APIs is you can chain them together to kind of attack each other. So you can get one site to attack another site, and so on and so forth. And basically, through that proxy function, you can attack as many sites as the URL length will allow, which is, some of these have to be because for safety reasons, they have to encode. But so if you URL encode it, you should be good to go on the proxy function. So that's the security mechanism, I guess. They were worried about people trying to XSS people or something. But some of the larger themes of this is this API is now being used in a way that it wasn't intended. And that's with all of this stuff. It's abusing the functionality to potentially get one site to attack another site and so on and so forth. Okay, now comes the fun stuff.
Okay.
So cross-site request forgery is, and it's always hard to kind of explain this because I like to think we know what we're talking about with this, and we kind of go back and forth. Well, yeah, it's kind of like.
It's kind of like.
Yeah.
It's kind of like. Actually, I had a conversation with somebody that does. There's kind of people that do the web stuff, and there's people that do, system, exploitation and things like that. And I said, well, it's kind of like return to libc because it's already built in.
Oh yeah, it's
function.
exactly like return to libc.
I don't know. But the one that I find usually makes kind of, even though actually there's some things that are not ideal about that particular paper, there's a paper that describes it as session writing. And that's one of the other problems too, is that people keep trying to give different names for it. But if you think about session writing as an expression to define it, what you're really talking about is you're already authenticated into a site. A target user is already authenticated to a site. Their session data, headers, authentication, cookies, any other information is already there. You don't need to steal it. It's already there. What you're doing is essentially getting that user to do something in the context of that site without their knowledge that they didn't intend to do. So you're riding on their session.
And previously thought of, you have to have full knowledge of what the request would look like. Mm-hmm. So there can really be no randomness to that data. It has to be very static. Yeah.
And if you go out and read, most of the papers about XSS and most of the sort of published now I'm messing it up. If you read the published papers and write-ups on CSRF, they usually describe a password reset function on a bulletin board, and that works. And there are places where that's out there, and it's silly and retarded, but it still works. That's embedded in the image tag, that just basically calls that function. Somebody surfs that page, it resets their password, right? The one place where you kind of see XSS described as something that's less sort of fixed and static is in reference to, when you see cross-site request forgery. God, kill me now. Referred to as something that's less static is when it's kind of combined with XSS. And so it's kind of understood that if you have an XSS on a site, any of that session data is accessible to you. So you can forge requests on the behalf of that user and pull things out of the DOM like their tokens or any other information that you want to forge a request. And so when you see it done in a less static way, it's usually due to XSS.
So it's a really silly attack. There's nothing elegant about CSRF. It's really dumb, but people take a lot of offense to it when you write something up in your blog, like you can take over all Motorola and Netopia DSL modems with one request. They tend to get a little touchy about that, and they tend to not be kind. So I guess let's just get into it. Yeah. So one thing with CSRF is it doesn't have to be a web site on the web. You can attack local network devices. You can attack the local host. Anything that's running a web server can be attacked through cross-site request forgery. Classical CSRF, we already went through that. We don't need to go through this diagram.
Yeah, well, actually, it's just real quickly, just like an obvious scenario, you as a victim go to bad.com, and sitting on bad.com is something on a site you're already authenticated to that's calling a function that's repeatable and replayable, right? And actually, to speak to things like home routers and cable modems and stuff, there's a guy actually that's doing a talk at DEF CON on the two-wire modems and routers, which if you have UVerse, that's everybody. In Mexico, there was a big fish that went out targeted at, I think it was something like 5,000 users, that reset their firewalls and changed their DNS to a malware site so that they could control the traffic. And that was just an image in an email that did that from those routers.
Okay, this is still live, so be kind. Let's do a demonstration of a post-based CSRF attack. Now this is using Monkey Fist, which when we get into later, makes it extremely easy to pull off post-based CSRF attacks. So anybody who says it's more difficult to pull off a post than a get-based CSRF is absolutely wrong. This is Newsweek.com. They basically have the ability to, log in and manage different things. So it's hard to see, but we're logging in as Bob Smith and with the old password.
Of old password.
Yeah.
And then after logging into that, Bob pops over to one of his other
Favorite sites.
and he
Called
likes to do-
Craigslist.
No, actually.
Oh, Reddit.
Called Reddit, and at the top of the political news articles, he saw a article that said Sarah Palin resignation due to leak of nude photos. And so that caught his interest. He clicked on that, and it actually took him to.
It happens really fast, which is why it's hard to detect.
Yeah.
It was a hidden post that basically reset Bob's password and took him to Benny Lava on YouTube.
And this was from in the case of that one, I think an is-good URL. So it was a shortened URL that took you to a destination of YouTube, which it could have even been to an actual, Newsweek article or something. But in between that,
So we logged out, and now we're going to log back in with old password. And we get no ability
Failure.
to log in. So if we go to our payload, which had the password of epic fail, we log in. So a couple of things made this more dangerous. One, if you notice, it never asked for the old password first, which is a really dumb thing to do, because that would stop some of this cross-site request forgery stuff. But it also, when it was sending the data, it never asked for the username anywhere in the request. It was set in the cookie, so it was set in the session data where it knew which user was logged in, which makes this a global password reset for anybody that runs across the content, which makes it obviously much more devastating.
and you'll see a lot of times sites that will do a lot of things in headers and cookies and things like that, and sort of see that as some way to validate what's going on the site. But if you have the ability to forge the request, you don't really care that you have a strong cookie and a good session ID or anything else. None of that stuff really comes into play.
So let's get into some more interesting scenarios that were thought to possibly, that weren't really thought of too much. This is something we're calling dynamic CSRF. And what it allows us to do is to set up a payloads file, basically, and perform attacks based on domain. So whatever domain comes in, it'll have a payload specified for it, and the tool will run that payload.
Yeah, and just to sort of hit on this, when you see people describe it as very much like this kind of static, like image tag kind of thing, if you actually read the original Pete Watkins paper, and actually it's not really a paper, it's just like a post to bug track where he sort of defined, this sort of attack class. He talked about exactly that kind of scenario. If you put these protections in the URL and things like that, if there's ways that an attacker can obtain that information, all that really means is they have to dynamically construct the request. But nobody really noticed that. And so if you ask people what CSRF is, they typically will describe this like static kind of thing.
We can just go past that.
Yeah, and sort of, examples of that. There was a recent XSS with Bitly that, that whenever that was described, it talked about, that you could use that to then dynamically kind of construct things via the XSS. The SAMI worm was kind of a dynamic XSS. So it enumerated parts of the user's profile and constructed a custom kind of payload for each user.
When you start thinking of CSRF dynamically versus this static attack, there's a lot of scenarios that open up. There's a lot of different things you can do with it that previously weren't available. Obviously, it makes post-based CSRF much more easy to pull off. It's not. It's no longer this process of setting up multiple pages and then trying to get people to click on them. And you can reconstruct the token if it's leaked in cross-domain fashion. So if you have a token in the refer, it'll take the token out of that refer and package it up into the payload and send it to the user's browser and execute.
And then something that we kind of actually stumbled across in the past couple of weeks is what we sort of describe as token fixation, where you might have, we talk a lot about referrer leakage and using that to obtain tokens if they're in the URL, right? So if you have, offsite content or a link offsite somewhere or some way to get the user to a site under your control, you could pull it out of the refer. But we've also found that if tokens are not mapped to a user session and they're not paired up to a given user, you can just log into the site, send your authentication data, and if you can dynamically construct the forgery, if you can feed that user your token and that works for some valid lifetime.
The next example we have is exactly that, because that's the most complex type of attack to pull off.
Yeah.
Is the fixation type attack, where you're actually requesting data and you're fixating it onto a user session.
Yeah.
So
and yeah, just basically like we identified a lot of things like this. And when you look for CSRF, you see a lot of things that are not get-based, or there's some unique bits that are sort of per user session. They might not be tokens. It might not be something that's really secure, but it makes it a little trickier. It's a little tougher than something that's a trivial kind of CSRF.
and we have diagrams of these two
Yeah, and a lot of those sort of non-trivial CSRFs, there's an assumption if you talk to developers and stuff that they'll say, well, as long as we don't have XSS in the site, doesn't sort of same origin come into play? And it might, depending on the way the tokens are issued, but it might not. And additionally, another thing that actually just came out, and I think he's here, so I have your blog on this page, so you have to now say, hey. Okay, so maybe not. Hey. So just recently, Jeremiah Grossman had talked about using CSS style sheets to enumerate. So like you guys have all went to that webpage where it says, I can guess what sites you've been to, I can guess your browser history and stuff. Well, if your tokens are in URLs, it's the same kind of thing. So that's part of your history. So the Inferno security blog, and I have no idea what your actual name is, so the Inferno security blog, did a proof of concept of using CSS history to brute force tokens if they're in URL. And so that's that's kind of like a dynamic kind of CSRF scenario.
So here we have a simple diagram of one payload file to rule them all, basically. So you can put your attacking content in one spot and run attacks on multiple pages and sites, and it will handle the attacks for all of them. So enter Monkey Fist. This was interesting, and this is live right now. If you go to hexsec.com/labs, there's a simple little link that you can click there to get to the Monkey Fist folder, and please let me know if there's any wicked bugs, and don't beat me up too bad on some things because it was just finished recently. It was meant to be a simple POC to only do redirects, and it grew into handling the handlers we're going to talk about, even the fixation handler, which is kind of experimental right now. So if you're going to use this for testing, use it at your own risk because you might get varied results. It's written in Python, and it's a small Python web server that listens for anything that comes in and then makes a determination on it. So if you're trying to be innocuous, you could have it point to spacer.gif, and it will just handle based on the refer that comes in. It has a payloads.xml file that you're probably all going to beat me up for because it probably makes no sense. There is a README, so please read the README before sending me email. And it automates the per request dynamic CSRFs. It can do hidden posts, redirects. It does refreshes to legitimate destinations. So if you saw the first CSRF scenario we gave, how they ended up on a legitimate end page, and that was YouTube Benny Lava, you have the ability to specify that in the payloads file. And it will take any kind of tokens that you specify out of the request that comes in, repackage them into a legitimate payload that the user's browser will execute. And I'm just going to go through these a little bit. It's simple XML, so make sure that it's encoded properly. But these are the options, and they're all in the README, so I'm not going to bore you with them now. But basically, you specify a site in that payloads file, and that's what's going to be matched when the domain comes in. The number thing here, the payload n equals, that's for a random attack handler that hasn't been written yet. So if you try to run it with attack R, it's going to puke on you. That's coming as well. So it matches the site, then it looks up the method. So you have get, post, page, and this is old. There's also fixation. And the ID would be your token values that you're trying to steal. You can steal as many as you want out of the request. So for every single ID, that is some piece of session data that you're taking out that you want to repackage into your attack, whether that be a redirect, whether that be a post-based attack, page-based attack, or a fixation.
And you could be pulling those out of the refer if it's available. So you could be, if you have cross-domain refer leakage and tokenized URLs, and we can get you to something under our control, we can look at all those pretty little JSession ID and other values and say, okay, we'll just map that request and send it back to something else. But if those aren't available, they can also go out with the fixation piece that we have a demo on in a little bit. It'll go out and just get the tokens itself if the client will accept them and send them along.
Well, the client will always accept
Well, the
them.
client will accept them,
whether
the server
whether
may
the
not.
application accepts them after you construct them is a different story.
Yeah.
But target, guess what that is? Headers, you can add header values to your post if you're doing a post construct attack, so you can add any header you want and any header value you want. Post variables, post values, and those are in pairs. And the destination is where that meta refresh is going to go. So your ultimate destination would be your legitimate link that you want people to end up on. And this is what it looks like. This is kind of an example payloads.xml file. So you kind of have it descending into the XML. And you can change it on the fly too, by the way, since it reads the XML every time the tool executes. So you can make changes on the fly. Just hopefully they don't hit the payload type while you're making changes. Otherwise you'll see a nice little stack trace. But it will keep running.
We saw a lot of stack traces.
Yeah, a lot of stack traces. So here's the example of doing a simple dynamic redirect attack with the tool. So somebody makes a request for content on a page that an attacker has the ability to link to. The second part is it sends cross-domain data to the tool. The tool creates a redirect with the session data attached, and then for the redirected now good request with all the session data gets executed on the site. Post construct is a little different. Something that started to happen when CSRF started to become more popular is people are like, wow, the session ID is random. Why don't we just use that to protect our requests? So it becomes really bad when you leak that information into your refer, because now the user's browser isn't even needed to execute requests. So if you can properly construct the post without the user's browser, if you're leaking enough session data, the tool will do that as well, and that's only like a 3-step process.
And actually something that occurred to me at like 4 in the morning last night, typing these slides, is that this same kind of approach, as far as being able to create a post in the context of the client, and there's some other tools that allow you to kind of test for that too. This is also a pretty easy way to make viable payloads for post-based XSS as well.
The dynamic page attack is kind of fun because that's also what allows you to pull these post-based CSRF attacks off more easily than was previously possible. So you have an initial, request that goes to the tool, and it sends back a legitimate and an illegitimate location, and the post or gets to, will be constructed in the background. And this is good for situations not only for post-based CSRF, but if you have a page that you can't link images to, but you can link hyperlinks to. So if something says, no, you can't do markup, but will it link to something? So if you say, here's my homepage, here's my blog, whatever, you can click on that and it'll still work. Okay, and then I guess the fixation one isn't in here?
Well, I think
or is it after
that's
the
basically
demo?
I don't think it is. So that's basically the demo here is
Presentation fail.
presentation fail. So
That's the most interesting one at the moment. So
yeah. So actually, this one we kind of figured out about a week ago that it was another kind of edge case for CSRF where there wasn't sort of a clean way to do it, by hand. And again, that's basically, and you see this a lot now because people are starting to kind of bolt on some kind of level of CSRF protections on their sites, but those and like examples being OWASP, CSRF Guard, and things like that, those don't necessarily hook into the app. So
It's disjoint data basically. So you have this disjoint session token protection mechanism, and it's not tied to the user's session. So in that case, any valid token will work for constructing it, and that's part of the fixation attack.
So if the token's valid only for one use, you need to be able to give a different token to every one of those forged requests in order for it to be successful. So if you have the logic to go out and pull that down from the site and feed it back.
Yeah, and there's lots of to-dos. If you feel brave enough to look at my source code, there's lots of to-dos in there. So yeah. So here's, okay, set this up a second. This is gonna look like absolutely nothing to you. I wish we were like Billy Mays up here with the WoW demo. But this is really WoW, it just doesn't look like it.
It was a lot of work.
Yeah, it was a lot of work.
It was a lot of work for us.
So this is the most complex example we could really give, even though it doesn't look that amazing. Mainly because there's different values that had to be queried and returned and posted onto the session. So here's Wikipedia. And what we're gonna do is edit the CSRF entry on Wikipedia. So if you look down here, you'll see forging login requests, and it goes right to prevention. And scrolling up, and then you'll see over here we have Craigslist. So if you go down, we're going to buy a truck on Craigslist, and we're interested in buying a cheap truck.
$100 truck right there.
$100 truck right there.
Truck. There.
So there's a link on here to more photos, which is actually a bit.ly, or is good or something.
I can't remember which one. It doesn't really matter.
So what's happening now is a request is being made to Wikipedia, and they got basically lava rolled into watching Benny Lava. And
I think we're the only people that actually think that's funny, though. And that's okay.
So if you'll notice, there's a new entry on the CSRF wiki that basically says other approaches to CSRF.
And describes that you can do things, in a more dynamic sense, and some of the other things that we just talked about.
Yeah. So I can think of no better way to edit that entry than to CSRF it. And if you look at the comments for that, the comment just says "win" for that edit. So
woo! Yeah, it was like 3 a.m. But we finally got it after a number more tries than we care to admit, actually. But so yeah, basically what you saw there was a per request unique CSRF of just an anonymous Wikipedia edit. The requests themselves could be replayed back to the client. They weren't mapped to a user or a session because it's an anonymous user. And actually, for what it's worth, this bug is there's a CVE ID for this from December, where somebody else had identified overall the CSRF in the Wikimedia app. But when they corrected for it by creating tokens that do map to individual sessions, they only did it for logged in users, right? So in our case, an anonymous edit, you can still do that, but it's still kind of doing a triple LUTs and spinning a little bit to the side because there's all these other session values that are unique to the entry. So there's a WP edit time and a start time that every time you click edit on the article is generated, and it's basically Unix time, epoch time. All these other kind of session values have to be constructed for that to work. So we went and requested all those session values. When you click the add, we got the latest edit time, the latest start time for the article, and then fed that back to the client. So yeah, we thought that was cool. Just random, kind of black helicopters theory. The Church of Scientology was banned from editing Wikipedia for affecting bias, and there's actually a guy that did a talk at Hope like 2 years ago called Wikiscanner that talks about looking at corporate authorship of Wikipedia, right? Because it's supposed to be this kumbaya, community authored kind of thing that's all collaborative. But there's all these neat little edits that happen, like one of my favorites, because it's a St. Louis company, is Anheuser-Busch owns SeaWorld, and there was a section about mistreatment of orcas that mysteriously was excised out of the article from an IP address, that company. So just black helicopter theory. You could still do all those anonymous edits, remotely. Just put a truck on Craigslist or something.
So this is kind of, oops, that would have been. This is kind of how the payload was set up for that. We left the actual actual text section out of it, mainly because it was long as hell and it would have looked like crap on the slides, not because we were trying to hide anything. But this is kind of set up. Method was fixation, target, destination. ID source was another value that grabs the IDs. So there's still a long way to go with this stuff. And bolting on, you might be bolting on some fail. So that's...
Yeah. And I want to make the point about sort of everything that we're talking about, all of the well understood like methods to mitigate CSRF. If anything we look at with the tool does all of those things right, then it's not applicable. It's not, it's not sort of this whole new attack class for CSRF. It's just that doing all of the right things to prevent CSRF is a lot harder than, say, doing all the right things to prevent XSS. You have to validate your refer. You have to create tokens that are unique to individual user sessions that are mapped, on a per request basis. You have to, look at the input that you fed to the client and what comes back. All of those things have to be done correctly. And if you leak that token information somewhere, it's still broken.
Yes, and if you find a problem with the tool, please let me know. It will stack trace very nicely for you, so if you send me that stack trace, I can kind of go back and fix that. I have a couple of things coming out on my blog about usage of the tool and how to set it up, because it needs LXML, so if you don't have that installed. But that's only for the fixation handler. And also, too, the slides and the paper, the white paper on dynamic CSRF will be up hopefully today or tomorrow on hexsec.com. So if you go to hexsec.com docs section, and of course, Hexsec Labs has the tool that you can download and then make fun of me because of my coding.
So thanks, guys.
Thanks.
Thank you.